All right, we're outside the Varjo headquarters in Washington, D.C. Varjo is a company that makes military-grade VR headsets and training suites for pilots and sea captains and Humvees and tanks. So basically all military-grade stuff for training. It allows the pilots to be a lot more immersed without having to go out and actually fire up the F-35, which happens to be very expensive. So we're gonna jump upstairs with Sebastian and hopefully get to test out some pretty cool stuff. Let's check it out.
So here we have two examples of some of our highest end hardware, our XR headsets. These are both part of the XR4 series. You'll notice that they look identical, but there are actually some pretty important differences between the two depending on the customer. So on the left here, we have the Focal Edition headset. The reason why it's called the Focal Edition is that it provides a really superior pass-through experience, a really superior mixed reality experience. And the way that actually works is this is the first headset in the world that has what we call autofocus. So you'll see two 20 megapixel cameras on the front here, the left and right camera. Whenever you wear any mixed reality headsets and they have these mixed reality cameras in the front, they're typically at a set fixed focal plane. So you can kind of think of it like I'm taking a photo with my iPhone, and sometimes I tap on certain areas and I'm able to change the focal length of the camera, right? I'm able to change the focus if it's something far, if it's something close up. These headsets and the mixed reality cameras on them and that autofocus system is able to do that automatically, continuously. And so what that means in practice is if I'm wearing this Focal Edition headset, I can be looking at an object that's close up. The cameras will automatically determine how far away that object is with the help of this LiDAR sensor in the middle. And then knowing that information, it will adjust the focal length of the mixed reality cameras automatically. And what that means is you're always getting the sharpest mixed reality image wherever you're looking all the time. That system is working within 200 milliseconds, within the blink of an eye, always adjusting on the fly so that you can get the best mixed reality experience no matter what you're looking at. So now we're going to take a look at the XR4 Focal Edition headsets. As I mentioned previously, it's got two 20 megapixel pass-through cameras on the front of the headset. We've got a LiDAR sensor on the front as well. But then looking inside to the headset, maybe you can grab a shot of the displays there. You'll notice these are pretty wide aspheric dome lenses covering 120 by 105 field of view. And I believe, if I'm not mistaken, these are 4K by 4K resolution displays per eye. So lots of resolution packed in here. You've actually got almost 29 million pixels across these two eyes. It's pretty high res. And you've even got some special features that you don't see on any other headsets. On the top, you've got some ambient light sensors, which can detect how much light is coming in from the real world and adjust lighting of virtual objects in real time, of digital objects.
Wow, that's really cool.
You've also got some tracking cameras on the corners so that we could do inside out tracking or we could do outside in tracking with base stations.
Hey, real quick, I wanted to explain to you guys what inside out tracking is versus outside in tracking. Inside out tracking, as the name may imply, is using onboard sensors of the VR headset to understand where that headset is in the physical space. It uses onboard tech like the cameras to do computer vision and LiDAR to do light detection and ranging. And typically we take all of that data and we crunch it into a system called SLAM. And SLAM is a technology in the back end that's kind of mathematically crunching all of this data into a 3D map so it can understand where it's at in the physical space. Outside in tracking, however, relies on external sensors around the room that communicate with the headset so it can understand where it's at in that space. Now you know. All right, back to Varjo.
So now we're going to take a look at a quick overview demo showing some of these specs in action so that you can get a look at what this looks like. You can see the resolution, the full fidelity, the field of view, the mixed reality. You could also see the colors, the color gamut coverage, and the contrast of these displays, which is what really makes them one of a kind. Like, you know IPD, right?
Interpupillary
exactly,
distance, right?
Exactly,
Yeah.
exactly. So for most people, that ranges from like 50 to 70 millimeters. But usually if the display alignment is off from your IPD, it makes a really big difference. It contributes a lot to motion sickness when you're wearing headsets.
Okay,
so
right.
the calibration system that's doing is twofold. One, it's actually changing the distance between the displays, each display, so it matches your IPD. So every time someone new puts on the headset, it's going to look for your eyes. It's going to perfectly match the screens to your IPD automatically.
That's really neat. There's a little touchpad here, and that's like automatically setting your IPD. And you'll see like a little green dot on the screen. So traditionally, like on like a Meta Quest, if you're familiar with those, you have to like actually spin a little dial and it moves in and out, like mechanically. Is this a digital?
It's all automatic. So there's like,
it's actually moving.
There's little motors that are moving.
Oh wow. Okay, that's
someone comes in.
That's cool.
With a bigger IPD, you'll feel it like move. You'll notice it. It's much nicer.
And now you know why it's more expensive than the Meta Quest 3, for one of many reasons.
Just keep staring at your dot.
Okay. Oh, is it still working? It's working its magic? All right, we're in business.
Okay, so even before we start a demo, how about we do this real quick? I'm gonna hand you a piece of paper. It's got quite a lot of text.
Okay.
And it's pretty small text, so it's hard to see a lot of this text in regular headsets. But I want you to just hold that at a couple different distances and get a sense of how the cameras adjust and how sharp it looks at different distances.
The sharpness, so when I get this close, I mean, with anything, it's blurry, right? Yep. Even in real life. Here, it's focused, and as I move out, it's staying focused. Like, it doesn't matter how far I get, and it's all readable. So I can read it, or you can take my word for it. I'll read this. The TAA certification, the XR4 Secure Edition and U.S. Trade Agreements Act. Okay, you get it. So you can read it. It's pretty cool.
Yeah, so that's pretty small text that's hard to read on most mixed reality headsets in general.
Yeah.
But I want you to even try like holding this up facing that eye chart. There's an eye chart in the background here. And you can kind of just move your eyes between the small text and the eye chart.
Oh, wow. Okay.
And you see how that autofocus
starts to autofocus. Okay, that's really neat.
Yeah,
so as you move your eyes, it's tracking your eyes and it's autofocusing to where you're actually looking, right? And that's also tied into like the foveated view. Right.
Yeah.
So that's basically it's only
like,
rendering what you're looking at instead of wasting time and energy on, for layman's terms, on outside stuff.
It's basically like foveated rendering, but for mixed reality, if you can think of it that way. Like foveated rendering is really popular in VR because it's a way for you to just sharpen the area you're looking at only in VR, so you don't need to render the whole display. Right. But this is almost the same, but for mixed reality. At the same time, that autofocus system works great in mimicking how your eyes actually work. Your eyes are actually changing their focal distance or their focal length. Like your lens is always adjusting based on what you're looking at, how close it is, how far away it is. So this system mimics that entire process using the LiDAR sensor to see where you're looking, using the eye tracking sensors on the inside of the headset to see where you're looking, and then doing all that math, that computation to adjust the focal plane
extremely fast.
Blink of an eye. Yeah. You saw how quick it was.
It was like really impressive. Also, like what I'm seeing is as I look at the window and I look back over here, it's adjusting the white balance.
Yeah.
So it's getting a little dimmer when I look out, so I can see these buildings, so it's not washed out white, which is really neat. So that's another awesome feature.
Yeah. So now we can get you into a quick demo and see what that looks like.
Cool.
Chris, if you want to fire up that intro demo.
Fine. This just kind of gives you like an idea of the color scale.
All right. I'm in space. The color looks awesome. I'm looking down at Earth, and yeah, this is so neat. This is so sharp.
So
I mean, this is so nice.
So this is something to like note about Varjo headsets and these types of headsets. It's like, you know, you hear a lot about resolution and high resolution displays. And resolution is really not everything, right? You need like contrast, you need great colors, you need great like local dimming capacity. This headset has all of that. So you get really true to life colors, you get really dark darks, you get really bright colors.
Yeah.
There's great contrast between all of it, and you can see it pop out in a scene like this.
I'm so excited for people to be able to see this. I want to make sure I'm looking around and not missing anything cool.
Yeah.
And you can see the galaxies out there, the stars are really neat. I mean, this is like, obviously just like so much nicer than a Quest 3. Even the Apple Vision Pro, I think this looks better. At least from I've had very light experience with the AVP, but this looks great.
So this is simulating the old XR3's field of view. This was
Okay.
our last generation headset. And when Chris presses the space bar here, you're gonna see the full field of view come to life. And so this
Okay,
shows you
so
the
this is, oh,
difference
got you.
in terms of like, the biggest difference was primarily in the vertical field of view. And there's actually a like definitive use case reason why that's the case. We had a lot of fighter pilots doing their own training and simulation with this headset. And when you're in a cockpit setup, you actually need a lot of vertical field of view to be able to see your knees, the cockpit, your feet, and all of the instrumentation under you, but
Right.
also the real like digital world that you've simulated around you, right? Outside of the plane, right?
Should we test my eyesight?
You gotta give it a go.
Yeah, we'll pick a line.
Hi, Dr. Chris.
Hi, Dr. Chris.
Be the lowest line that you can read. Upper E.
Straight to the test.
Oh, it looks like FDFLTCD. Oh, that might be EO.
Perfect.
Yeah.
Nice.
So
That's
nine's-
what my eye doctor always says.
There you go.
Perfect. The bottom. I'll try the bottom. All right. FEZOLOFFD.
Good.
Good. Not perfect.
That's just what my eye doctor says. Good.
Oh, okay.
He always says, no matter what you get, if you get all the letters wrong, he'll just say perfect or good. So it's something to keep in mind next time you go to the eye doctor.
Question on the eye doctor thing, actually, because if someone has bad eyesight and they put these on, like you don't have to wear glasses, or will it auto adjust to someone's, like their eye type?
The headset itself can't do that. There's no headset on Earth, I guess, that could do that.
Uh-huh.
But there are like prescription lenses that we would sell on our
Okay.
last generation headset. And I think we also have XR4 inserts, if I'm not mistaken.
Okay.
They're prescription inserts that can be put on top of the lenses, and it will basically adjust the lens kind of like your glasses would. So it's almost like putting on
Sure.
glasses on your headset. And that way you can get a sharper vision.
Okay, cool.
There is also one cool thing I can show you here, actually, on the topic of glasses.
Okay.
There's a button on the right here, which you'll probably feel with your index finger. It's a little bit further up. Yeah, that button.
Okay.
If you press that and kind of pull the headset out a little bit, like physically pull it.
Oh, whoa.
So that'll adjust the like.
Okay, like binoculared in. If I could explain it verbally.
Yeah, so the display panel will literally move out a couple of millimeters, probably about
Wow.
an inch, and give you more space on the inside. So if
That
you
actually
wear,
helps my. This is like even a little sharper now.
okay,
Yeah, I prefer it like that also.
yeah,
Just a tad bit out.
yeah, you can wear glasses.
Wow.
on.
Okay, so like super versatile for people of all kinds of eyesights.
Yeah.
And facial types, structures, and it's. Oh, by the way, we're like what, 10 minutes in.
Probably.
This is super light. Like it feels so good on. Like,
Yeah.
You wear an AVP, aka the brick, like your forehead hurts after like a few minutes. It's really nice. It's really well weighted.
Nice.
Yeah. Good
Yeah,
job.
the ergonomics on that, it's got great balance, got great counterweight. It fits the back of your head well. That's actually one of the heavier headsets you'll find on the market. I think it gets
Yeah.
close to a kilogram, or probably in the 900 grams region. So it's
Okay.
got a lot of tech packed in there, but you wouldn't even notice it because it's balanced really well on your head.
Yeah.
So after that calibration is finished, you're gonna see this this environment showing with a heat map overlaid on it based on where you're looking. You'll see what I mean.
Oh,
It's,
all right. That's so cool. Yeah. So this is great for like studying how your users are using the experience, right?
yeah, absolutely.
And this is how you could like really start to isolate in like what's good, what's working, what's not.
Yeah.
Super cool.
To give you a really like concrete idea of how this is used practically in the real world, our biggest segment of practical usage with XR is flight simulation. And that's flight simulation for not only defense, but also for civil aviation use cases. In this case, you could have a civil aircraft, maybe it's a 737, 787, this kind of model, and you could train commercial pilots using an XR simulator on the environment, on the actual cockpit. While you have them in this setup, obviously you have the eye tracking working, and you could get some analytics from the pilots, understanding what they're looking at, when they're looking at certain things. Imagine them running through a starting procedure or a checklist procedure and getting an understanding of what they look at first, what they interact with, and doing a bunch of analytics based off of that.
Yeah, that's
So
amazing.
it's kind of like training jacked up to 11, because now you not only do the regular training sequence and you see if you pass or failed, but you can also see a lot of analytics as to why you might have passed or why you failed, you know. So there's you can get a raw CSV file that's recording like pretty much every millisecond or something like that, where your eyes are looking, when they're shifting, where in the scene they're looking, like tons of raw data that you can use for your research.
I'm just gonna use this window for reference, and then like my verbal action. It's very snappy. So we'll start top left to the window here. Bottom right, left, top right, left, bottom right, top right, bottom left, middle. It's immediate. The eye tracking is wild.
Yeah.
It's super accurate, and like not just generally where you're looking at, but like pinpoint exactly. I'm looking at the pin on the fire extinguisher. It's nailing it. It's really cool.
Yeah, the eye tracking module itself runs at 200 hertz.
Okay.
So it is really ping continuously, like making sure that we can get a full understanding and an accurate understanding of where your eyes are looking at any given time.
Wow. Yeah, really impressive. You'd mentioned there's a pretty notable difference between these two. Although they look very much alike, there's something that makes them very different from each other.
Yeah, absolutely. So on the right side here, we have the Secure Edition headset. So it still has the same autofocus capability. It's still like a focal edition headset, but the difference between these two is its security, and primarily where it's manufactured and how it's built. So the one on the left is manufactured in China. The one on the right is manufactured at our own manufacturing line in Finland. The benefit of the one on the right here is that it's TAA compliant. It can go into the most secure environments. It can even be configured to have the radio frequency components removed. And so all of this creates a package that's really compelling for XR in the defense industry. And it allows you to bring these headsets in the most secure environments and get your training and your simulation needs met without having to run across any of the barriers or restrictions you typically have with regular consumer commercial headsets. Okay, so outside of just training and simulation and defense use cases, we also see a lot of commercial use cases for XR technology. And one of the biggest that we've seen in the past is this automotive design use case. So you can think of vehicle manufacturers when they're designing new cars. This is a traditional process that's very labor intensive and very material intensive. You have big blocks of wood and of clay that are manually being formed by automotive designers in order to iterate on and to get to a vehicle design that you're going to be planning for the future. Now, this is a great way to physically conceptualize and build out a vehicle at full scale, full dimension. The problem with that is these are multinational companies, right? They exist all across the world, in Europe and in Asia and in the US. And when you have this physical chunk of wood or clay that you need to ship across the world for review and for executives to take a look at, that process is logistically challenging and it gets quite expensive. So you could imagine if you could create that whole process in XR in a virtual world, in a virtual 3D world, using some sort of engine or 3D software, you could build out and continuously iterate on that next model, that next design vehicle, and ship that instantly across the world, because that's a digital file. And so in this case, what you're going to be looking at is a virtual Volvo, which you can see in full fidelity. You can get a sense of the scale and the quality, but also the small details that really make or break kind of the automotive design. And you'll explore, as you're looking around that Volvo, you'll be able to see how impressive that fidelity is and how valuable this use case is for automotive designers. So they no longer have to rely solely on just the physical components and the 3D files on a 2D monitor. But now you have a way to review and to design a vehicle, a next generation vehicle, using XR hardware.
Wow, that looks insane.
Yeah, so this is
The reflections are nuts. That's so cool.
This is a Volvo. I think it's an XC60, if I'm not mistaken. I'm not sure exactly which model it is.
Oh, the mirrors are so cool.
But outside of just defense, we also do a lot of work in other industries as well. And one of the largest use cases for XR is automotive design. So you can think about designing new vehicles. Doing so is like a whole process, right? There's an entire like wood molding process, a clay molding process.
Right.
The way it's traditionally done is with these huge like 1,000-pound hunks of wood and clay, right?
Yeah, right.
And you'll have designers physically carving out these blocks of wood and clay. The problem is, you know, these are multinational companies. You know, you think of a Toyota, a Honda, a Ford, like pretty much every one of these large auto manufacturers have bases in Europe. They have headquarters in the US. They have bases in Asia and Japan. Shipping 1,000 pounds is expensive. It's logistically hard, it's challenging, it's expensive to get executives from around the world to see and review this next upcoming model that they're designing.
As you can see, the detail is amazing. And as you move, the reflections change, because this car in its 3D environment from over here has, it's like a skybox or an HDRI around it, right? And that's like of a parking garage or something. So it's got these really realistic screens or just reflections on all the materials. So that's what gives it this extra layer of realism, and all the materials look very realistic to real life. Like the rubber looks like rubber, and the rims look like the rims, and that metal looks different from the car metal. So it's really cool how actually like robust the materials can get in XR. Yeah. Like it's like we've gone so far from where we used to be. It's just like, it's incredible what you could use this for
sure.
So now, oh wow, this is cool. We could take a peek at this.
Yeah.
So they just added in a skybox, and now we're sitting in, it looks like Italy. I've been there. This seems like Italy, if I had to guess.
I think it is.
Is this a, okay, this is really interesting. Oh, there's a moose. Check it out. Neat. That was cool. I wasn't expecting that.
Seen that. I've never seen that in this demo.
That was tight. Yeah, look out for moose in Italy. It's a known problem. So yeah, this is so cool, because this is like, man, like pitching a client on a new car design and putting it in Italy, and it's this like inspired by that region, or you know, something that's like kind of what the project was about. Say it's a Ferrari, you can put it in the environment and place the person that you're showing, your boss or whoever you're pitching the concept to. You can like immerse them in your idea, and that's just something that we never really had before, unless you took them there and showed them the physical thing in the place. So it's just like the things that we can do with this now for sales or for design, et cetera, is just, it's expanding very, very rapidly. So as you can see, just incredible fidelity on this this demo.
Okay, so this is going to really blow your mind. Look very closely.
Oh, is this the sensors? Is that from like reading our room?
Not quite, but just look very closely at those reflections and see what you see.
Okay, let's get in here. It's this room. Like I'm seeing the floor.
Yeah.
So this
is this room. So what it's doing is,
because the ceiling looks, oh, it is this room now.
Yeah.
It looked different on the hood. Now it's switched to this.
Yeah.
Whoa, is it? All right. I can guess, or you can tell me what it's doing, or both.
Give it a shot.
I can give it a shot first. All right. So these cameras obviously have something to do with what's going on.
Yep.
And they're looking at this room and creating an HDRI, I imagine, of some sort, and then it's using that in the 3D modeling software to then reflect onto the surfaces to give us a live, in your environment screen space reflection.
It's pretty much there. What it's doing is it's building a cube map. It's continuously like building a cube map of that environment and using that as the reflective probe, is my understanding. I might be wrong on some of that, but as I understood, it's basically, really, you're going to notice a little bit of delay in that reflection versus what's happening in the real world, because it needs to like understand how the real world has changed. But that's an updating cube map, so you can see the real world reflections in this digital vehicle.
So there was just like an artifact. The light was like, there's like a half of a light over there, and then as I looked around, it fixed it.
Yep.
Wow, that is incredible, dude. That is so cool. I've never seen anything like that besides Simulon, and I don't know if you're hip to it or not.
I've heard of it, but I'm not familiar with what they're.
Basically you would take like this 3D model or any 3D model into their software, and you scan your room. So you do like a full 360. Yeah. And it understands the light, basically what this is doing live. Yeah. And then you can then place objects into your video and like shoot a video, and where you scanned, and it's reacting like this is to your environment's lights, which is like blows my mind, right?
Yeah.
Because now you could do like VFX in your room.
Yep.
And have like just like realistic to your lighting, and if you adjust it, it changes. Really cool. That the core difference is that's baked. Yours is reactive to what's changing in the environment.
It can be reactive. I think this demo might not be per se, but you could use those ambient light sensors to change the reflectivity and the emissiveness based on like how much ambient light you have around you. And that takes it like to a whole nother level, because the reason why I would do that is if I'm standing in a room like this and we turn off all the lights and it's nighttime, or we turn on all the lights, the virtual object should look very different in mixed reality. Because if that was a real object and I turned off all the lights, it would go dark. I turn on all the lights and it would have like spotlights in certain parts of the car, right? And so in theory, you'd be able to use the ambient light sensors to mimic that same kind of experience, but with a virtual object.
Yeah. So if you were to change the light right now and like turn it up, the reflections would, I would imagine, look different, right? As it rescans.
Let's try it. I don't think we've tried this in a while, but let's see. So now we're on max lights. I don't know if the difference is big enough to where you can tell. I think on the roof of the car.
But on the roof of the car, yeah, I think you did see that.
That light bulb was on for sure.
I'm getting a new scanner to see. Okay, so yeah, it's updating at least the lights in the reflection.
Yep.
Are brighter.
Yeah.
But like, I don't know if the actual like car itself has gotten brighter.
Yeah, in this case, the car itself wouldn't have gotten brighter because of what I was explaining to you there, with like you would need to change the actual like virtual lighting in the scene to match the real world lighting. So the way the car itself would get brighter is like you would make a virtual light probe in the 3D world, in the digital world, that would change depending on the data from the ambient light sensors.
Shout out to Chris for holding on to my avatar bracelet.
That's actually one last little thing I want to note about this. We obviously have wired headsets. People ask us all the time, can you build a wireless headset? Why aren't your headsets wireless? Why aren't they standalone? The main reason is twofold. One, those two displays you have, I'll try and sneak into your camera view here. Those two displays you have, one in each front of your eye, is pushing 4K by 4K resolution. It's a lot of data to be pushing. And so obviously you need a pretty high powered GPU to run this at a high FPS. On top of that, the mixed reality cameras have a lot of data throughput passing as well. It's 20 megapixel cameras. So this cable is pushing 10 gigabytes per second of data all the time. And so that's why we need a cabled experience, is to push all of that visual fidelity to your headset continuously with a very smooth experience.
Awesome. And you guys don't have any wireless headsets, right?
We do not.
All right, because
we do not.
Your focus is on like the highest quality possible experience.
Yeah, that's
and
right.
This is the way to get that at this point in time.
Right. That's
and
right.
Maybe forever. No, we'll see. We'll see what compute and like hardware can catch up and do in the next few years. But
maybe not forever. You know.
Because like, I mean, to get this, like, that's actually a good question. To get what we're looking at now.
Yeah.
What would we need to see for a standalone untethered device? What would we need to see in the hardware space happen?
You'd need to see the compute level up quite a bit. The standalone chip that powers most standalone headsets today is the Qualcomm chip, the XR2 Gen 2. It's that Snapdragon one, right? And so that headset has a good amount of compute, but for these really high-end visualization requirements, you know, where we're talking about tens of millions of pixels and tens of millions of polygons, and that's a strong requirement, and you're going to need a lot of visual fidelity to push through this. I think the best way to think of this is basically two 4K monitors strapped to your face.
It's what it feels like.
And so if you try and run two 4K monitors on a standalone headset at the same time in VR, it's tough. It's tough today. But that's not to say that it'll be tough forever. You know, I think there's a world where that changes.
Cool. You guys want to jump into the F-35 pilot simulator?
Yeah, let's try that.
Let's go. We're going to jump into the F-35 sim, but there's two cats over there that have captivated our attention. Look at them. What's up, guys? This is my Top Gun moment. All right. Air Force just got a new pilot. All right, so we are in the F-35, right? Is it F-35?
Yep.
cockpit, which is like, I think the most advanced known, at least unless it's the most public-facing advanced U.S. aircraft, right? For fighter pilots. There's a lot of buttons. I don't know what any of them do. I know this thing does, this red one shoots rockets and stuff. So we're gonna probably play around with that a lot.
See that pedal adjustment?
There it goes.
That'll bring
that
it
was
closer
nice.
to you. So is that the right
Good action.
Does it need to get closer or is that good?
No, that feels good.
Okay, so now I'm gonna give you a quick rundown of how the controls operate here. So you've got landing gear is this switch. So this is your throttle on the left-hand side. And at about 80-90%, you're gonna feel that first resistance. Push it forward even more, that's afterburners.
All right, we're gonna be trying that out.
Let's see what else is relevant. I think the most important thing you're gonna wanna figure out is shooting. And this is kind of complex, so bear with me. In the MFDs here, you can see in this flight display in the front of you, you're gonna notice this missile status on the bottom left area. You're gonna have two types of missiles. You have AIM-120s and AIM-9 missiles. You'll be mostly firing these AIM-120s, but the way this works is you're gonna find a target, one of these red targets on your radar. You're gonna point your aircraft toward it, and there's gonna be a button on your thumb, which I can show you on this side.
This red one?
It's actually gonna be this, like almost selector button that you're gonna change up and down. And you can see how when you press up on this, it engages that as a target.
Okay.
To fire the missile, you're gonna press that red button.
Okay. So how do you switch targets?
You'll notice when you're like pointing or facing toward it, it will automatically engage the next target.
Okay, gotcha. There's a missile. Oh, there it goes. Whoops. All right. All right.
Wait, hold on.
Just launched one into the hills there. Cue up Top Gun.
I think, well, I guess that's how we...
The danger zone.
I'm clearly not a pilot. I don't know what I'm talking about with that. But my point is...
Shoot these things.
If you have an E-pad there, you would be able to read that text in full fidelity. And this is where that vertical field of view comes into play that we were talking about for this training and simulation. So as you're looking straight ahead, you can still kind of see it in the periphery below you. You can see the bottom like half of the cockpit. You can see a lot more of the cockpit than you would in any normal headset.
So can you explain kind of how you achieve that, where I can see this physical cockpit and touch all these buttons?
Yeah.
But everything around me looks like I'm on a tarmac, or I'm on a carrier. I'm on a carrier.
Yeah. So the way this works is it uses this technique called masking or mixed reality masking. And what that is doing is it's basically cutting out an area of the real world at a predefined size. In this case, we want to cut out the exact cockpit that you have here, the real world cockpit. And the way that works is we basically upload a 3D model of this cockpit into the software and tell the headset and the software to cut out this area from the virtual world and to show the real world instead of the virtual world. And so that's how you see this real world cockpit. You're basically seeing the feed from the mixed reality cameras through this 3D model shape of the exact cockpit. And then we were talking a little bit before about like, how do you align an object? How do you anchor it? How do you make sure it's in the right spot? Like, how do we know that this 3D cockpit cutout is in the right space as the same real cockpit?
Right.
And the way that happens is up at the top of this, there is a tracking. There's like a Vive tracker here. So this is an anchoring tracker, which will tell the rest of the system the position that this like cutout needs to exist in 3D space.
Right.
And so that's why this cockpit is so well aligned.
Yeah, it's incredible.
Versus it being
occlusion's
completely
perfect.
off.
Yeah, it's insane. And even in here, I have like AR overlays out in front of me, showing like my tilt and a bunch of other metrics that I don't know what they are, but
yeah,
it's really, really neat.
All right, let's get you in the air. Yeah, if you push your pinky outward, like further out. Yeah, all right, you feel that?
Yeah, I pulled at it.
As soon as you feel that, you're gonna get launched off.
Wow, planes are fast. Okay. Wow, this is so cool, guys. So we are at full speed here. Let's see if we can lock onto a target. Locked onto a target.
Yep, and you're gonna press that red button on your thumb.
Wow, dude, look
Set a
at
missile
that.
off.
That's so sick. That's nuts.
Look at that, you're a natural.
No, we can. Yeah, the Army's gonna call me up this week. Well, there it goes. See if we can inspect our shot here. Wow, this is like so cool. I've never experienced anything like this in my life. The last time I did any sort of flight simulator was at my grandpa's house when I was like 10.
I imagine this is a little bit different.
It's just like a little. I was working off like a Dell like an old school like Dell box computer.
Yeah.
And it was just a little less sharp. Just a little less sharp. Wow, this is fun. This feels like that scene from Top Gun when they dive into the canyon.
Yeah, you never.
Yeah. So God, I'm crashing.
Oh. No worries, we can restart you there.
The terrain. After I crashed already. Thanks. I would love to play like a game. That'd be so neat to be like multiplayer in this. Can you get like you can get multiple of these in and like actually have them do dogfights for training, right?
Yep.
Yeah, that's so neat.
That's right. We work with a number of system integrators, or what they're called, which are the companies that put together the whole package you see here. So the headset plus the software plus the physical cockpit you're sitting in and all these bits and pieces.
I mean, before this, like the only way to train was in a plane.
Yeah.
And you're talking about a cost savings of like a significant amount of money, right?
Yeah, something I also want to point out is, like, physically speaking, if we wanted to, we could fit multiple of these simulators even in this room that we're sitting in right now and have them wired up together. So it's also a really efficient use of space when we talk about these VR simulators.
And I imagine they got like a bunch of different training maps for different training scenarios.
Yeah, the beauty of XR and of these simulated environments is that the possibilities are really endless in terms of what you can simulate. Whether that's the number of users involved in a training scenario or where it is located, right? You could have a training scenario anywhere on Earth with terrain environments.
How accurate is this to like actual speeds of these planes, like as we're, our perspective of passing buildings and such, right?
So the accuracy is really high, but on top of that, what really makes these virtual simulations stand out is the realism in the physics as well. The way the aircraft moves in the air, its aerodynamics at certain speeds, how it interacts while stalling, like all of this is accurately modeled in the physics engine, so that you're getting a really realistic experience. So it's not only about the visuals, but it's also about how you can interact with the world in the aircraft and ensure that that's as realistic as possible as well.
Outside the simulator, like the flight simulator itself, the headset is just pushing excellent graphics the whole time. It's not lagging, it's not glitchy. I'm not seeing any artifacts. It's excellent. It's really, really cool. And a lot of that's probably attributed to being tethered, right? So what is actually, I'm curious, what's the hardware that's running right now to the headset?
Let's see if we can find out. Let's take a look.
All right, well, the CPU, it's an Intel Xeon W5, 16 cores, 32 processors.
Probably one of the most powerful CPUs. You also have 256 gigs of RAM. And it looks like a 4000 ADA is in this right now. 4000. Oh, there's an adapter for a 6000 ADA. So I think
there's two in it then. So there's an ADA 6000 and an ADA 4000. And you said 256 user RAM. I can even see that. Pretty.
Flying upside down is an experience. And just looking down, that's so cool. It's the full Top Gun experience. It's amazing. Everyone has to try this at least once in their life. This is like nothing like you've ever experienced before. So cool. Like this is what technology, man. What we could do with really creative ideas. Change the world. This is remarkable.
I mean, if you think about it, you're flying a real expensive piece of equipment, right? The aircraft you're flying is over $100 million for sure.
Right. I just crashed it 3 times. I've done $300 million in damage in 15 minutes.
Exactly.
But it costs no one anything.
We got to build a leaderboard sometime soon to see who can rack up the most.
Can you please? That'd be great.
But this is like, we joke about this, but this is kind of the benefits of having this sort of simulated training realism, these trained environments in XR devices and in XR simulations. Like the reason why this is so valuable is that you can practice these very high risk technical scenarios where there's a lot involved, there's a lot at stake, right? And it's very technically challenging to perform correctly. So the training is of ultimate importance.
Watch me lace these buildings, bro. I was born for this.
There you go. There you go.
Sorry, you were saying.
No, you're good. You're good.
Let's go. We almost added another 100 mil to the leaderboard.
Tag that,
We
boy.
still got it.
And so
I still got it.
my point in all of that was like you're training really expensive equipment, really technical expertise required, really high stakes environments. You know, this is what XR excels at. This is what XR technology is perfect for, because you don't have to take the same level of risk. You can train at full fidelity, at full realism without the $100 million potential cost involved there.
And no hard deck.
Yeah, exactly.
You can fly 12 feet from the ground if you want, and no one's gonna yell at you.
Yeah, exactly.
There's 400 million.
Just reload it over. You know, it doesn't even matter.
Yeah.
Wow, that was so incredible, dudes. Got the VR headset here. All right, that was so fun. My hands are actually sweating from like I feel like I'm flying in an airplane.
That realistic.
Yeah, and it's fast. It's responsive. It's super realistic. So like the graphics are like super real. Yeah, it's only gonna get better. Like that's where we're at now. It's gonna be fascinating to like hear actual pilots and what they think about going through training like this and how realistic it is for them versus being in the actual plane itself. Maybe you have some insight on that.
Yeah, we do. I would highly recommend checking out Varjo.com, and you'll see a lot more there.
Shameless plug. That's a great website. All right, let's jump out. We're gonna check out teleport.
So we're going to take a look at a teleport scene as well. Obviously, everything that we showed you up until now is our XR hardware, which is what we've excelled at up until now. That's been our bread and butter. That's built our business up until this point. But we've also been building software at the same time that we feel has a lot of utility to these XR use cases and outside of XR. The most obvious example that we're working with today is called Teleport. And so Teleport is a 3D Gaussian Splatting application. It's a product that turns regular RGB imagery from practically any camera into 3D GS scenes, like the one that you'll see on the display here. And so we're going to take a look at this scene, and we're going to show you really what's possible and what bounds you can push with Teleport and with 3D Gaussian Splatting as a whole today.
All right, cool. So right now we're loaded up into teleport.
Yep.
And we're looking at almost what the flight simulator looked like. It's like an overhead of a small town. You can use your mouse to drag and click around. And so this is a Gaussian splat, right?
Yeah.
And this was created with a drone
Yeah. So
flyover.
to give you a little bit of rundown as to what the space is. So first off, shout out to Andriy Shramko. He's the one who captured all of this data. He captured it with the DJI drone, and this was all captured anywhere from 100 to 200 meters of elevation, all using just imagery. So again, this is just RGB camera input, just a camera on a gimbal on a drone. In this case, it was almost 15 to 20,000 images that were captured and compiled.
Okay.
That was all brought into Teleport, and with nothing else but just the images uploaded to the platform, we were able to produce this output. So this output you see here is 100 million Gaussians.
Okay.
It's, I think, about 8 square kilometers, and you can get a sense of the space around here and how large this space really is.
All right, cool. So we're like down into the buildings here, and wow, it's like crazy how high a fidelity like just random objects are. Like this trampoline, for instance, just looks really good. Where like these things can get pretty funky, right? Because you got like netting and these weird materials. I see some like ghosting in the cars in here, which is pretty common with splats.
Yep.
Depending on how big your scan size is, right? Or if you're using photogrammetry versus LiDAR, you get a little bit different results, right?
Yeah, I think even in this case, like, you know, again, all of these images were captured at like 100 meters plus above the ground.
Wow. Okay.
So being able to resolve this level of fidelity when all the input imagery was that high up is really impressive.
Would this be called like sparse image rasterization?
I wouldn't
like-
say sparse image because we did have a lot of images,
Or view dependent?
But there is some view dependency here. So a lot of Gaussian splatting has view dependency.
I'm learning stuff.
And the way that's working is it's essentially changing some of the colors and properties of the splats, like the transparency, depending on what angle the camera is at, where you're viewing it from. And so that's how you can get really impressive results and photorealistic results. You'll notice this is especially obvious around bodies of water or reflective objects or anything like that.
So what do you think are some of the biggest use cases for something like this right now?
Yeah, great question. So we do a lot of work within real estate currently today. We actually do a lot of real estate exterior capture visualization. So you can see single family homes, multi-family units, apartment buildings, all sorts of different types of residential real estate and even commercial real estate from the exterior view like this. Yeah. So this is a really great technology to visualize those properties in full 3D efficiently and to bring that onto any device. And I think our primary focus with Teleport is giving you an automatic pipeline to be able to create these Gaussian splats automatically and at scale. So we talk about something like real estate where there are millions of homes being sold every year just in the United States. If you want millions of Gaussian splats created, that's a hard challenge to do, even if you have all the data. And so what we do is solve that problem. We provide you a pipeline to where if you can supply us that data, we can supply you all these 3D scenes automatically and at scale. So you're not having to do configurations, you don't have to do settings, you don't have to be an expert in 3D GS or really understand how all of the little parameters and tweaks and features work with this tech. We will handle all of that for you, and we will give you the best result output here.
Amazing.
So there's so many trees in this space, and photogrammetry just can't do this. I mean, it just cannot resolve this level of detail with anything that can render at this speed. And when I take a look, I see this running at 200 plus FPS. So this is a very capable scene that we've got here, and a very capable rendering engine, which can show you just the level of detail that's possible. But yeah, I think it's most impressive when you take it all the way from the furthest view, and you can see just how large this space really is.
I guess one quick question, like hosting, if I want to host my splats onto Teleport, I could do that.
Yes.
I already created my own splat.
Yep.
I can just upload it that way.
Yeah, you can upload a PLY file and we can support that and we can view that splat as well. And our bread and butter is really going to be on the reconstruction side. So being able to create splats from imagery, whether that's photos or videos. But yeah, if you have already created splats, you can view them as well on Teleport.
So even if you don't have an expensive scanner, you can take a video or a set of photos and create yourself a splat on the Teleport platform.
Yeah,
that's amazing. Is there like a free playground so people can like test out like putting stuff onto Teleport?
There is right now. Yeah, there is right now. I don't know if there will be when that video goes up.
Thanks again for showing us around.
Yeah, I appreciate it.
Varjo studio. Thank you for letting us try out this awesome simulator. This is Chris. Chris is in the background doing all sorts of helpful things, moving us through the experience today. I wanted to give Chris a shout out. Chris was not paid to make this video. Chris did it out of the kindness of his own heart. He's a great man. He's a great man. All right, so I hope you guys found that as exciting and fun as I did. That was so cool to go out and test all that. Big shout out to Teleport and Varjo and Sebastian and Chris for being such great hosts. Thank you for having me out. I had a blast in DC. I look forward to coming back and checking out what you guys cook up over the next year. That was a long video. Thanks for sticking through it. I think it was just too good to clip. I think there was so much good information in there. I didn't want to leave it out. I thought Sebastian did such a great job educating us on all the different parts of Varjo and their different headsets and Teleport. So I hope you guys came out of that with like loads of information you didn't know. And you feel a bit more educated even as an advanced person, and I hope all the newbies were able to follow along. I tried to break some things down as we went, so I hope you enjoyed that episode. Thank you so much for tuning in as always, and we'll see you guys on the next one. Peace.